Machine learning. Introduction to machine learning. Machine learning, ML, is a discipline of artificial intelligence, AI, that provides machines with the ability to automatically learn from data and past experiences while identifying patterns to make predictions with minimal human intervention. Machine learning methods enable computers to operate autonomously without explicit programming. ML applications are fed with new data, and they can independently learn, grow, develop, and adapt. Your time to program codes and everything decreases with the help of machine learning. Main scope of machine learning is to save time of people and make the machine as your friend. It also has potential to do the work that the normal being can't do with the conscious mind. Machine learning also changes the way you normally think in its learning. The performance of ML algorithms adaptively improves with an increase in the number of available samples during the learning processes. Suppose you are building some product which is based for global audience, and also you want to target the audience, allowing them with multiple languages. You may not be able to do that or need to start from scratch for each language, but with machine learning you can do that easily by just collecting the data and feeding it into the machine learning. About machine learning also changes your way to learn. Types of machine learning. 1. Supervised learning. Supervised learning is a type of machine learning where the model is trained on a labeled dataset. This means that each training example is paired with an output label. The goal is for the model to learn to map inputs to the correct output. Examples. Classification, assigning a category label to an input, e.g., spam detection in emails. Regression, predicting a continuous value, e.g., predicting house prices. The confusion which people face is what is labeled dataset. Labeled dataset. Definition. A labeled dataset is a collection of data where each example, data point, has a corresponding label or target. This label provides the ground truth or correct output for that example. In other words, each piece of data is paired with the answer or outcome we want the machine learning model to predict. Example, consider a dataset used for spam detection in emails. Each email, data point, would have a label indicating whether it is spam or not spam. The emails and their labels might look like this. Email 1. Win a free iPhone now. Label, spam. Email 2. Meeting rescheduled to 3 p.m. Label, not spam. Email 3. Exclusive offer just for you. Label, spam. In this dataset, the text of each email is the input data and the label, spam or not spam, is the corresponding output. Importance in supervised learning. In supervised learning, the labeled dataset is used to train the model. The process involves the following steps. Input data, the input features or data points, e.g., the text of emails. Labels, the correct outputs or targets, e.g., spam or not spam. Training process, the model learns the relationship between the input data and the labels. It adjusts its parameters to minimize the difference between its predictions and the actual labels. Prediction. Once trained, the model can predict the label for new, unseen data. Examples of labeled data in different contexts. Image classification. Dataset. Images of animals. Labels. Animal species, e.g., cat, dog, bird. Example. An image of a cat is labeled as cat. House price prediction, regression. Dataset. Features of houses, e.g., size, location, number of bedrooms. Labels, house prices. Example, a house with specific features is labeled with its price. Medical diagnosis. Dataset, patient data, e.g., symptoms, test results. Labels, medical condition, e.g., diabetes, no diabetes. Example, patient records with symptoms and corresponding diagnosis. Visual representation. To make this concept clearer, imagine a simple table. Input data, features. Label, target. Win a free iPhone now. Spam. Meeting rescheduled to 3 p.m. Not spam. Exclusive offer just for you. Spam. Each row represents a data point, an email, and the label tells us the correct classification for that email. I'm only giving you general idea here about the types of machine learning with one type. I will make a whole detailed video on it with all the types in detail here. It wasn't my main motive to go into types, but was to make you to have a general idea of it, so I covered some part of one of the types, supervised learning. Coming back to the main topic, which we are trying to focus actually. How does the machine learning works? You must have got some idea from the diagram how do AI work, but I am here to explain you all in detail. The training data is used to train the machine learning algorithm. The testing data is used to evaluate the accuracy of the trained. Clear the above point as it's important to understand the difference for this also. 1. Training data. The training set is the material through which the computer learns how to process information. Machine learning uses algorithms. It mimics the abilities of the human brain to take in diverse inputs and weigh them in order to produce activations in the brain, in the individual neurons. Artificial neurons replicate a lot of this process with software, machine learning, and neural network programs that provide highly detailed models of how our human thought processes work. For example, suppose you see that the CAPTCHA verify you as a human. First, it used to ask you to click the correct images to prove you as human, but now it only asks you to select the checkbox and you are all set to visit the website and proved yourself as a human on some pages. It's just because machine had been trained about how to actually humans move the mouse and how much time it takes it for a human to select and all other internal aspects, and trained about all of this by the data collected by humans. Training data can encompass a wide range of examples beyond just human behavior patterns. It includes any data used to teach the model to perform a specific task or recognize patterns. 2. Train the ML algorithm. Training algorithms are a class of algorithms used in machine learning to tune the parameters of a machine learning model from a training dataset. The goal is for the model to be able to generalize and make accurate predictions about new data that has not been seen before. Training algorithms can be supervised, unsupervised, or boosting. Supervised training algorithms use a labeled dataset to learn to map features to known labels. Unsupervised training algorithms are used to learn patterns in an unlabeled dataset. Finally, reinforcement training algorithms are used to learn to make decisions based on feedback from the environment. Examples of training algorithms include stochastic gradient descent, SGD, the backpropagation algorithm, and the Captions clustering algorithm. Stochastic gradient descent is one of the most widely used algorithms in machine learning to adjust the parameters of a machine learning model. The backpropagation algorithm is used to train artificial neural networks. The Captions clustering algorithm is used to group data into different clusters. 3. Model input data. Model input data typically refers to the information or data that is provided to a machine learning model for training, inference, or prediction tasks. This data can include various types of information, such as text, images, numerical values, or categorical data, depending on the specific problem the model is designed to solve. For natural language processing models like ChatGPT, input data usually consists of text inputs that the model processes to generate responses or perform tasks based on the context and patterns in the data it has been trained on. 4. Prediction. After the model has been trained, it can be used to make predictions on new, unseen data. This stage involves providing the model with new input data, which the model processes to generate predictions. These predictions can take various forms depending on the task, such as classifying images, predicting numerical values, or generating text. For example, in a spam detection system, the trained model would analyze new emails and classify them as either spam or not spam based on the patterns it learned during the training phase. The accuracy and reliability of these predictions depend on the quality and quantity of the training data, as well as the effectiveness of the training algorithms used. You all can refer my notes below for better understanding if you are not able to understand something.